Okay, so we are on Unit 8B, point 3. Okay, so we're on 8B.3, and what we're going to be working on today are some special log rules. The log rules are special. Special log rules and graph logs. Okay, so we're going to work on some special log rules, and we are going to be graphing logs. Okay, the first rule that we gave you was a couple days ago. Okay, first rule was if you have log base b of a equals e, that can be converted or written in exponential form as b to the e equals a. Okay, b to the e equals a. So that was our first rule. And hopefully we all kind of remember that one. That one is just to move between exponential form and log form. Okay, so for example number 1, I would like you to simplify log base 1 of 1 equals x. Log base 1 of 1 equals x. So if I'm simplifying, the first thing you want to do is rewrite this in exponential form. So here x is the exponent on 1 that makes 1. What would x equal there? What about 0? What about negative 1? What about negative 5? Negative fraction or negative exponents make fractions. 1 over 1 is still 1. Is there an actual answer here?
No solution.
Not really. Okay, x could be 0, 1, 2, negative, could be any of those numbers. Therefore, anything that has a 1 on it, okay, log base 1 of 1 is no solution, okay, or undefined. You do not have to write out the words. I just want the symbol. So the 0 with a slash through it. That's your answer. Okay, this is not a problem that we can do. Let's try another one for number 2. Same thing, I want you to simplify log base 5 of negative 25 equals x. Log base 5 of negative 25 equals x. How would I write this in exponential form?
5x equals negative 25.
5 to the x equals negative 25. So what power of 5 gives you a negative 25? Can anything make a positive, any power on a positive make a negative?
No.
Does not work, okay? This does not work. Therefore, again, your answer is no solution. All right, no solution there. Another special one. Number 3, if I give you log base x of 9 equals 2. I want you to simplify log base x of 9 equals 2. This doesn't work? Oh, you better check this one again. 2 is the exponent on x that makes 9. Really? Nothing squared gives you 9? No. For sure it does. What's your answer here?
X equals 3.
Really? Is that it?
No.
It used to be positive or negative 3. Okay? Remember, when we put in a square root on both sides, you have to put in a plus or minus. This used to be an answer of plus or minus 3. When we are dealing with logs, okay, when we are dealing with logs, you only write the positive answer. Okay? You only write the positive answer. Because of these, okay, we're going to write a rule here that's going to help us to simplify some things. Okay? The rule is that your b, which is your base, and your a, okay, so remember that's your base and a of answer, must be positive. Okay, your base and your answer must be positive. And also, b cannot equal what? What can your base not be? 1, or b cannot be 0. right? So that's a special one. Your base and your answer must be positive. Also, b cannot equal 1 and cannot equal 0. The kind of easy way that I like to remember this is I remember that logs are allergic to negatives. Okay, logs are allergic to negatives. So if you have anything here in the base or the answer, okay, if you have either a base or an answer next to the log on the same side as the log, it's going to be no solution. Okay, it's perfectly fine to have negative exponents. That's okay. But you cannot have a base or an answer of a negative number. Okay, questions so far? So just remember, logs are allergic to negatives. Okay, let's try another one. I want you to simplify again for number 4. Simplify log base 10 of 10 squared. Log base 10 of 10 squared. If I rewrite that in exponential notation, how would I write that? 10 to the x equals 10 squared. You drop the 10s, and we get x equals 2. We did something like this yesterday, yes. Okay, let's try another one. Number 5. Log base 7 of 7 to the 4th. Log base 7 of 7 to the 4th. Write this down. 15. Log base 7 of 7 to the 4th. How would I write this in exponential notation? 7 to the x equals 7 to the 4th. Drop your bases. X equals 4. Okay? Are you noticing a pattern here? Exactly. There is another rule or a shortcut that you can take. Anytime you have a log base b of b to the y, it will always equal y. Okay, so if you have the same base and answer, they go away, and it always will equal y. There's another way that I remember these, and I will often refer to these to you guys this way. I like to call these seagull problems. Okay, you guys are pretty, unfortunately, familiar with the seagulls at lunch, right? They swoop down, they poop on you, then they run away, or then they fly away. Okay, when you were, sorry, fly away. When you were really little, or when I was really little, and I wanted to draw seagulls, I'm not a good artist. So the way you draw seagulls, no, I didn't draw M's. I just drew like these check marks. Watch. This is what I like to call a seagull problem. Okay, it's not very mathematical. Watch. This goes away. That's your answer. This is my seagull. Same thing here. Seagull, answer.
Really weird seagull.
Hey, these are seagulls to me.
And what was wrong with you when you were
Hey, whatever. If you would like to do this whole process, you go right ahead. But I'm going to tell you the shortcut here is to seagull these problems. Okay? Down, up. If you would like to make up some other term for it, you go right ahead. But these are my seagull problems.
Next unit, there's going to be a turtle.
Okay? The reason I'm not going to say check mark is you'll see in these in just a second. Okay? Let's try another one for number 6. They look like check marks, but. Okay, number 6. Log base W of root W. Log base W of root W. I'm sorry, and for this last rule, this works for all values of y. There are no exceptions there. Sorry. Okay, for number 6, there are 2 different ways that you could do this problem, and I'm going to show you both. Okay. The first way is that you could rewrite this in exponential form. I would give you w to the x equals root w. You got the same base. This is w to the x equals w to what power?
1/2.
The 1/2. Drop the bases, and we could get x equals 1/2. Or the actually easier way to do this is to make it into a seagull problem. Okay? This could be rewritten as log base w of w to the 1/2. Then this seagulls away. 1/2 is your answer.
Amazing.
Okay? Does not matter which way you do this.
What if
They
it
both
was-
will give you the same answer.
What if it was
The
log?
seagull's all crooked.
Doesn't
What if
matter.
your, what if-
Okay, let's try another one.
What if your
For number
question was
7.
log base W to the root W, and then it had like a 1/2 on the outside of the root?
That doesn't work. I don't know what you're talking about. That doesn't make sense.
There's one like that. They had like the.
Okay, we'll get there when we get there. This is just, if you can make it so the exact base and this is exactly the same, then you can just eliminate them and you don't have to do this whole process. Okay, for number 7, 2 to the power of log base 2 of 8. 2 to the power of log base 2 of 8.
Yeah.
2 to the log base 2 of 8 power. Okay, the way we do this is you actually want to cover up this initial base. Okay, and first I want to simplify. What is log base 2 of 8? 3. So really this becomes 2 to the 3rd, which is what? 8. That's your answer. Okay, so you had to simplify first. Let's try another one.
That one?
Number 8. Okay, how about if I give you 10 to the log base 10
You can't do seagull that
of
one?
100. 10 to the exponent of log base 10 of 100. First, look at this part. This is, what is log base 10 of 100? 2. So 10 squared is 100.
You can seagull it.
Hold on. This is going to lead to another rule, okay, or another shortcut. Anything, a base to the log same base of x equals x, okay? Now, unfortunately, this one only works for some values of x. This only works for some values of x. What could x not equal?
A negative.
A 0, 1, or what else?
A negative.
A negative, right. 0, 1, or negatives. Okay, that could not equal a 0, 1, or a negative. Now, these kinds I would call an upside down seagull problem. Okay? If you go back to them, there's a shortcut that if you do kind of like an upside down seagull, that's why I don't call them check marks, because these are upside down. Those go away as well. Okay, so there's some shortcuts here.
It's a dead seagull.
A dead seagull.
Or a melody.
Call it whatever you'd like to. It's a shortcut. If you don't want to use it, I don't care. That's fine.
It's a gym because it looks stupid.
Okay, let's try another one. For number 9, example number 9. Again, I want you to simplify log base 10 of 1. Log base 10 of 1. Rewrite that in exponential form. What would that be? 10 to the x equals 1, and x would equal 0. Exactly. Okay, x would equal 0. What are we talking about? No, this is not undefined because 10 to the what power equals 0? 10 to the 0 does equal 1. That is not undefined. If it was flipped, that would not work. Okay, try another one. How about log base 5 of 1?
It's the same thing.
That's the same thing, right? So does it matter what your base is? Does not matter. Okay, this is not a seagull problem. This one is just a different kind of rule. Any base, okay, so log to any base of 1 equals 0. That's just kind of a shortcut that you're going to need to memorize. Okay, log to any base of 1 equals 0. Now, if you don't memorize these shortcuts, that's fine. You can always put things into exponential notation and then solve from there.
You're about to go over.
But these ones are a little bit easier. I got it extended. Number 11, log base 7 of 7. Simplify log base 7 of 7. if you rewrite this in exponential form, this is 7 to the x equals 7. 7 to what power equals 7? 1. Exactly. Technically, I see this also as being a Siegel problem. This goes away. What's the exponent if it's not there? A 1. So I don't really care which way you look at it. It's going to be the same thing. Okay, so another kind of shortcut rule is that log, if it's the same base as your answer, will always equal 1. So log to the base b of b equals 1. Yeah. It's okay. Thank you. Okay, yesterday we went over two kind of special, we went over one special kind of log, okay? Something called the common log. Okay, we went over common log yesterday. The common log is base what?
10.
Base 10, okay? Today, we're going to learn a different kind of log, okay? We're going to learn something called the natural log. Okay, the natural log is in what's called base E, okay? By the way, natural log is used in business. If you go to business school, I have a business major, you will always have to do a lot of base E stuff. I don't remember why, but it has a lot to do with different types of scenarios in business. Okay, the natural log is base E. E is a constant. Okay, E is an actual number, kind of like pi. Pi is 3.14 and it keeps going and going and going. E is the same thing, okay? Or not the same number, but E is the same type of thing. E is approximately 2.71828. That means it's not equal to, it's approximately 2.718281828. And it would keep going. It is an irrational number.
Why did you put it on the line? Couldn't you do that?
How was this invented?
No, you cannot put the line because it's not exact. They don't repeat exactly. There's no exact repetition. Okay,
Why do we have to do
point here is, listen, the point here is you do not want to approximate for E. We do not have to plug in 2.718 and keep going all the time. So the point here is you want to leave E as E. It's kind of like if you write pi. We like to leave things with pi in it because you don't want to have to multiply out. Same thing with E, okay? There's another thing that you're going to have to learn. Anytime we have a natural log, it's written as ln, okay? ln of y equals x. If you have ln, that stands for natural log. That's why I think someone in here asked me if you could just put L for log. You cannot do that because there's another log. ln stands for natural log. That,
It's gonna be NL.
anytime you see it, you should replace it
'Cause it's
with log
Spanish.
base E of y equals x. So anytime you see ln, that's called natural log, you replace it with log base E. Then that can be converted to be e to the x equals y.
Why wouldn't it be NL?
This is just the abbreviation. I'm not sure. It's like the mathematical abbreviation. It's not something I made up. It's just how things are in like textbooks and stuff. Okay, so natural log of y. Anytime you see natural log y, we replace it with log base E. Then you can rewrite it in exponential form. So if I ask you to write in exponential form, we are not solving, we are not simplifying. All you're doing is rewriting these in exponential form. For number 12, write in exponential form log base pi of 31.01 equals 3. You are not solving. You are just rewriting this in exponential form. So that's exactly what we did the first time, first day. So all you do is write here is 3 is the exponent on pi that makes 31.01. That's your answer.
Are we gonna have to solve it eventually?
Okay, there is nothing to solve for. Pi is already a known number that's in your calculator. So there's nothing to solve for. This is saying pi cubed equals 31.01. That's it.
So
There's no solving.
Is that even correct?
In this case.
It is correct. That is correct.
If I do know my calculator is wrong, I'll be mad.
Okay,
Wait.
try another one.
So we'll never have to solve that?
Well, we already know what it is. It's 3.14.
Natural log
So if we already know, why are we doing it?
20.01. You're not doing anything. You're just rewriting it in a different form. That's all I'm asking.
Why?
Because this doesn't quite make
It's a
sense.
California standard.
This one, pi cubed, does equal 31.01.
Oh, you're talking about ice cube?
Natural log 20.01 equals 3. Write that in exponential form. Natural log 20.01 equals 3. Immediately, as soon as you see ln, we are going to replace it
That's an in.
with log base e.
You should make the L, not the I.
Yeah, come on.
Okay,
Good.
natural log is always written as lowercase l, lowercase n. If you put uppercase, it's wrong. So it's always written that way. It just is. Okay? Anytime you see that, replace it with log base e, and then just rewrite the rest. Then take this and write it in exponential notation. So 3 is the exponent on e that makes 20.01. That's your answer. Oddly enough, your calculators always work in base 10. So if you have anything to the base 10 and we're trying to solve for it, that is something you can plug into a calculator. Calculators also work in base E, okay? But there's no other bases that you can solve for using a calculator. They only work on base E and base 10. Okay? Questions so far? Okay, now we're going to graph.
Yeah, there's only
Graphing logs. Okay, there are some steps to graphing logs. Step 1 with graphing logs is to rewrite in exponential form. Rewrite in exponential form. Step 2 is to make a table of values. Make a table of values. Okay. You need to look at the equation to see which letter, so it's either going to be X or Y. Look at the equation to see which letter, which is either going to be X or Y, is the exponent. Okay, so look at the equation to see which letter is the exponent. Whatever is the exponent, you are then going to, and put the numbers, sorry, I shouldn't have put a period there. Look at the equation to see which letter is the exponent and put the numbers 2, 1, 0, -1, and -2 in that column. Yep.
Is there any more steps?
Step 3 is to plot points and connect with a curve. These are very, very, very similar to exponential functions when we graph them. Okay? They're very similar, they're just barely different. Okay? So for number 14, if I was asking you to graph y equals log base 3 of x. Graph y equals log base 3 of x. First thing we need to do there is rewrite this in exponential notation. So how would you write this in exponential notation? 3 to the y equals x. Now, the reason step 2 is so long is because we know we're going to have to make that xy table. In exponential functions, I told you you always put the numbers 2, 1, 0, -1, and -2 in for the x. It's not quite the same here. Okay, you actually have to look at the equation whichever letter is the exponent. So here y, that is the letter that you're plugging in for. So we put 2, 1, 0, -1, and -2. So you have to look at the equation before you can decide which part you're plugging into. Then you just plug in. Okay, so we're trying to find the x. So 3 squared gives you an x value of what? 9. 3 to the first gives you an x value of 3. 3 to the 0 gives you an x value of 1. 3 to the -1, x value of 1 over 3. And 3 to the -2 gives you an x value of 1 over 9. Write this down.
I took up my whole paper.
Now we can go ahead and plot this. Okay, now we can plot this. Your first point is over 9 up 2. So over 9 up 2. Over 3 up 1. Over 1 up 0. Over 1/3 down 1. And over 1/9 down 2. Okay, so we're going to start this by connecting your dots. Connect them with a line. This is the exact inverse of an exponential function. Okay? This one, on an exponential function, it never crossed the x-axis and it got really close, or excuse me, it got really close to the x-axis. On this kind, it gets really close to the y-axis, but does not cross it. So it's the exact inverse of an exponential function. Any questions?
Yeah.
Can we do 15?
Nope. Okay, last one for number 15.
I'm not even close to being done.
Number 15, I want you to graph on the same grid. Graph on the same grid. I want you to graph y equals 2 to the x. And let's also graph y equals log base 2 of x. So we're going to graph both of these on the same axis. Same grid, excuse me. So first we'll start with the y equals 2 to the x. So again, we're going to make our xy table. What numbers, or excuse me, what letter am I plugging in for here? Do I put the numbers in for x or for y on this one? The x, whatever's in the exponent. So this is an exponential function. So 2, 1, 0, -1, -2. If you plug things in, we get y equals 2 to the first, or excuse me, 2 squared equals 4. 2 to the first equals 2. 2 to the 0 equals 1. 2 to the -1 equals 1/2. And 2 to the -2 equals 1/4. Go ahead and graph that. So that graphs at over 2 up 4, over 1 up 2, over 0 up 1, over -1 up 1/2, and over -2 up 1/4. So your exponential graph, remember, gets really close to the x-axis and then grows exponentially. Does not cross the x-axis. My log graph, first thing I need to do is change it to exponential form. So how do I write that as in exponential form?
2x equals y. 2 to the x equals y.
Y is the exponent on 2, so 2 to the y equals x. Then we're going to make that table of values. So make an xy table. What am I plugging in for here? For y, because that's the exponent. So 2, 1, 0, -1, -2. What happens here? These are inverse of one another. So we've already done all this work of plugging in. So you know if I plug in 2, I get 4. This gives me 2. If I plug in 0, you get a 1. Plug in a -1, it's 1/2. -2 is 1/4. If you plot these points, we go over 4 up 2, over 2 up 1, over 1 up 0, over a half down 1, and over 1/4 down 2. These connect, and these are exact inverse of one another. Basically, they're like mirror image of one another. Okay, they're exact, they're not opposite, we don't say opposite, but they're exact inverse of one another. Okay, does anyone have questions? Homework for this is going to be worksheet 3. You are doing numbers 1 through 25 all. Okay, all of 1 through 25.